with I have to multiply these two expressions. We do this using the distributive law. So x plus y multiplied by x minus y. Equals x multiplied by x minus y. Plus y multiplied by x minus y. That equals x squared minus xy plus yx minus y squared, which is the same as x squared minus xy plus xy. They're probably blocking the screen. Okay, so again, x plus y times this is x times this plus y times this. And that's what I've written down here. And then x times x minus y is x times x, which is x squared, minus x times y, which is minus xy. And similarly, y times the quantity x minus y is y times x, minus y times y. Y times y is y squared. This gives us x squared minus xy plus yx minus y squared. And of course, yx is the same as xy. And now we have minus xy plus xy, which gives us 0, and we get then x squared minus y squared. Now this idea can be used backwards. You see an expression that's the difference of two squares, you can write it like this. Okay. So for example, let's say you have 4a squared minus 9b squared. Okay. Now that's four a squared, the square of 2a. 9b squared is the square of 3b. So it's like this is x squared minus y squared. Or x equals 2a and y equals 3b. X squared minus y squared equals x plus y times x minus y then. Or a squared minus 9b squared, which equals square of 2a minus the square of 3b equals 2a plus 3b times 2a minus 3b. So that's one kind of important application of this idea. It comes up again and again. You'll see more of this in your open math homework, but make sure you pay attention to it and get the idea. Okay. Now, the other one, x plus y times x plus y. And of course, this is square of x plus y. Now, most everybody sees this and wants to write this as x squared plus y squared. It's like you have a distributive law of the exponent. Okay, but there's no such law. Okay, it doesn't work that way. If you multiply this out using the distributive law, you see that this is not x squared plus y squared. Okay. Square of x plus y is x plus y multiplied by x plus y. So this is by the distributive law, x times this plus y times. So there's what we do. And then we distribute x multiplication by x through this expression, multiplication by y through this expression, and we get this. Just to make sure we understand that yx is the same as xy, we'll go ahead and write out this step. And we see that when we square x plus y, we don't get x squared plus y squared. We get x squared plus 2xy plus y squared. Okay. So if you got this, or if you got this, you were this close. All I had to do is write this, and you see you get this. Okay. And this is another special product. The open math homework will run you through several examples of how the special product is used. As one example, if you want to do the square of 5a plus 4b, well, that's x plus y squared, where x equals 5a and y equals 4b. Since plus y squared equals x squared plus 2xy plus y squared, five a plus 4b squared equals 5a squared plus 2 times 5a times 4b plus 4b squared. Do we see this? Well, we've already said that this is the form x plus y quantity squared, where x is 5a and y is 4b. Since the quantity x plus y squared is x squared plus 2xy plus y squared, then the square of 5a plus 4b is the square of 5a, which corresponds to your x squared, plus 2 times 5a times four B, which is your two XY, plus the square of four B, which takes care of y squared. And then, of course, we can write this as 25A squared plus 50AB plus 16B squared. So the application of this identity, which you want to remember, allows you to square pretty much any binomial expression without having to go through the details of the distributive law. It's a frequent pattern, just like this is a frequent pattern that we see. So you want to get familiar with how this is used. I'm not sure I've even been recording it. I'll say I'm quite a bit under the weather today. Much better than yesterday. Okay, to multiply x plus y times x minus y. Use distributive law. So here we have it, and this will be x times x minus y, which we have here, plus y times x minus y, which we have here. Then if we multiply x times x minus y, we get x times x, which is x squared, minus x times y, which is minus xy. And then if we multiply y times x minus y, we get y times x minus y times y, which is y squared. And just to be sure, we can write yx as xy because the order of multiplication doesn't matter. And we get x squared minus xy plus xy minus y squared. Of course, minus xy plus xy is 0. And that leaves us with x squared minus y squared. So this is an important special product. X squared minus y squared is equal to x plus y times x minus y. So, for example, if I have 4a squared minus 9b squared, I can write that as the square of 2a, because if you square 2a, you get 4a squared, minus 9b squared, minus the square of 3b, which is 9b squared. The form of this is x squared minus y squared, where x equals 2a, y equals 3b. Since x squared minus y squared equals x plus 1 times x minus y, we have 4a squared minus 9b squared equals, well, x plus y times x minus y. X is 2a, y is 3b. That's going to be 2a plus 3b times 2a minus 3b. Okay. Then to square x plus y, we multiply x plus y times x plus y. So we get x times the quantity x plus y times the quantity x plus y, which then equals x times x, or x squared, and x times y, which is xy, plus y times x and y times y, which gives it a y squared. Okay. Then, since yx is the same as xy, we can do this. Unlike over here, where we had a minus xy or plus xy, we have plus xy and plus xy, so we get plus 2xy. So we have x squared plus 2xy plus y squared. Then, for example, if we want to square 5a plus 4b, we think of this, well, this is just like x plus y squared, where x is 5a and y is 4b. Since quantity x plus y squared equals x squared plus 2xy plus y squared, excuse me, quantity 5a plus 4b squared equals, well, x squared, x is 5a, so that's 5a squared, plus 2xy. Well, that's going to be 2x is 5a, so there's 5a, y is 4b, so there's 4b. And then plus y squared, well, y is 4b, so we get the quantity 4b squared. And then we can expand these. 5a quantity squared is 25a squared. 2 times 5a times 4b is 50ab. And the square of 4b is 16b squared. Okay, now we're working on this question. I'm talking about what we call greatest common factor. First, we have the expression 4a cubed b squared times 6a squared b to the fifth. Using the distributive law, we can write this as 2 times the quantity 2a cubed b squared plus 3a squared b to the fifth. Why does that work? Because 2 times 2a cubed b squared is 4a cubed b squared, and 2 times 3a squared b to the fifth is 6a squared b to the fifth. Now we can go further. We could write this as 2a times 2a squared b squared plus 3ab to the fifth. Why? Because a times a squared gives us a cubed, and a times a gives us a squared. And then if we multiply by the 2, we get our original expression. Now, you need to ponder that. You need to think about it a little bit, but okay. Then it turns out that we could write this expression as 2a squared b squared multiplied by a sum of 2 expressions. So what would we multiply by this? What would we put here? So when we multiply this by what's here, we get this. And what would we put here? So that multiplied by 2a squared b squared, we get 6a squared b to the fifth. Okay, so I've got to give everybody a little bit of time to digest this. So let's see how you did. Okay, we've got this term, this factor. This term is a binomial. Multiplied by this factor should give us this. What would we multiply by this in order to get this? Well, we're going to have 2 because we've got 4 up here and we've only got 2 here. 2 times 2 gives us 4. Then a squared times what gives us a cubed? Well, it's going to be a squared times a. Then that'll give us the a cubed. And then b squared times what gives us b squared? Well, we've already got b squared, so we don't need any more. We just need 2a. I multiply 2a squared b squared by 2a. I get this. Now over here, what do I need? I need 3 because I got to get 6. 2 times 3 is 6. I need a squared. I've got a squared, so I don't need any a. I need b to the fifth. I've already got b squared, so I need b cubed. Okay, does that make sense? I don't know when I have this on and when I don't. Okay, now some people have more trouble with this. Everybody has at least some trouble with this. So we want to make sure we know how to multiply expressions like this. Okay, and yeah, people did pretty well with this, but let's make sure. Multiply this by this, and we multiply this by this. Okay, well, if I multiply this out, 5 times 3 is 15. A times A cubed is A to the 4th. B to the 4th times B squared is B to the 6th. Five times 4 is 20. A times A squared is A cubed. B to the 4th times B cubed is B to the 7th. I think somebody had B to the 6th here, but I think it's probably because they copied this B cubed as a B squared. That's okay. That's just what the copying there, which goes back to my questionable handwriting. Okay. So want to make sure we understand how to multiply these things so we can talk about how to find the greatest common factor. So let me give you another one. Eight P to the 4th, Q to the 7th, multiplied by, oh, sorry, plus 6 P to the P cubed, P to the 3rd, Q to the 9th. Take the I want to say the biggest term you can out of these and put it out front and see what you get. Okay. Okay. Well, what number can we use here? Well, 2 is going to be the number. 2 divides 8 and 2 divides 6. And no bigger number divides both of these. So I'm going to have a 2 here. Now, the way to see this, what's the least power of P that you have between here and here? Okay, you got a 4th power, you've got a 3rd power. Well, we're going to use P to the 3rd. We've got a Q to the 7th and a Q to the 9th. The least power is the 7th power. So this is what we're going to factor out of the expression. Having done that, what do we have left? Okay, well, here we need 8. We've got 2, so we're going to have a 4 here. We've got a P cubed from this. We need P to the 4th, so we need another P. We've got a Q to the 7th. We only need Q to the 7th. I'm going to write it Q to the 7th. And then you check it. Because as I said, at least some people try something. Okay? If you're not getting it, check it out by multiplying. Okay? If I multiply this by this, do I get this? Well, 2 times 4 is 8. P cubed times P is P to the 4th. And Q to the 7th, we don't need Q to the 7th. So yeah, it's a good thing I checked it out. I almost made a really embarrassing mistake there, but I do that all the time. Okay, so we don't need any cubes. So there we have it. So if I multiply this by this, the 4 multiplies the 2 to give us 8. P multiplies the Q, P cubed, you get P to the fourth. We've already got Q to the seventh. Okay, then here, we're gonna need 3, because 2 times 3 gives us 6. We've already got P cubed, so we don't need any P's. We've got Q to the 7th, we need Q to the 9th, so we do Q squared here. Now, when you're first doing this, you want to check it, and at any time you're not 100% sure you want to check it. Using the distributive law, this times this, and this times this, plus this times this. And then 2 times 4 is 8. P cubed times P is P to the 4th. Q to the 7th, there's no Q over there, so we just end up with Q to the 7th. And then it's plus I never did write this. Okay. Okay, again, this times this here, this times this here. Okay, then multiply this, I get this, which agrees with what I have up here. Multiply all this out, I get 2 times 3, which is 6. P cubed, no P's, so we end up with a P cubed. Q to the 7th times Q squared is Q to the 9th. So this agrees with this. So there's a check. And this takes you full circle. If you do this several times in several problems, you'll understand. Okay. Let me give you another one. If 5a to the 7th c to the 4th plus 15a to the 6th c to the 8th. Okay, for this one, you got 5 and 15 here. You can divide each of these by 5. So you'll have 5 here. You have a to the 7th and a to the 6th. So you're going to want a to the 6th, at least to the powers of a. You got c to the 4th, c to the 8th. You're going to use c to the 4th here. And then the question just becomes what I need to multiply this by to get this, and what I need to multiply this by to get this. Okay, I multiply this by what to get this? Well, I've got 5 here. I need 5 here, so I don't need any numbers. I just need a 1 here, and I don't even have to write the 1. Okay, I've got a to the 6th. I need a to the 7th. Well, a to the 6th times a gives me a to the 7th. So a to the 6th times a gives me a to the 7th. And then I don't need any c's. If I multiply 5, a to the 6th, c to the 4th by a, the a multiplies a to the 6th to give me a to the 7th. I've already got c to the 4th, and I've already got 5. Okay. What else do I need over here? I need a 3. 5 times 3 gives me 15. A to the 6th. I've got a to the 6th here. I need a to the 6th here, so I don't need any a. I've got C to the fourth here, I need C to the eighth, so I need C to the fourth, and right there it is. And then if I multiply those out, I'm going to have 5a to the sixth C to the fourth times A times 5a to the sixth C to the fourth times 3C to the fourth. Multiply this out, I've got a to the sixth to multiply the a, it gives me a to the seventh. And c to the fourth times c to the fourth gives me c to the eighth. 5 times 3 gives me 15. And I've already got my a to the sixth. I'm going to have 15 a to the sixth c to the eighth. And this is going to be identical to this. And there's my check. Okay. Now you're going to see that. Let me take a look real quick.